before we continue this portion of the lesson 1, I suggest you to practice worksheets 1A and 1B about the internal forces. And now let's talk about the force and stress. What the difference? Force versus stress. So force, something that we are very familiar with in engineering mechanics. Basically, that will be the loads or reaction. And from that, we have a unit. It can be pounds. If in a US customary unit, or kips, kilopounds, kips, or Newton, kilonewton. So that is the force. And then the concept that we are talking a lot in this class is stress. In the daily life, stress is something negative. I'm stressful. I have a lot of stress, but that's not the stress we're referring to in this mechanics of material class. So what is stress we are talking about in here? Basically, it measures the intensity of the force. Measure of intensity of force. So, what does that mean? Basically, stress is the force per unit area. Force per unit area. Per unit areas. So what does that mean for the units? It also depends on the SI system or US customary units. If the force measured in pounds, for example, then the stress, it will be pounds over inch square. Pounds over inch square. And in this case, we're talking about PSI, pound per inch square, PSI, lowercase. And then if it's kilopounds over inch square, kips over inch square. And then we will talk about KSI, kilopound, it also lowercase. And then if we talk about the SI system, so we have the force in Newton and areas unit in meter square, so it will be Newton per meter square. And in this case, we also call it Pascal. So call it Pascal. And for this one, as you can see, the P capital and A is lowercase. And if we have it kilonewton per meter square, and then we have it kilopascal, K lowercase, P uppercase, and A lowercase, kilopascal. So those are the unit of stress that we have it in here. From the understanding of stress, which is the measure of intensity of the force, and the first type of stress that we want to explore is the normal stress. And before we get into normal stress, we want to explore a member that have centric axial loads, and that member we call it centric axial loaded member. Centric axial loaded cow member. And let's watch the demonstration of what is a cow member is about, and then we get into the detail. You see an example of cow member, centric axial loaded member. When you have a vertical column, orange in orange, standing there vertically, and if we have a load, for example, a black wheel on top of the member with the load go down from the weight of the block wheel, apply vertically and through the center of that orange column, and that load, and you can see it go down vertically through the center of that member, and that member with having that load, we call it cow member, centric axial loaded member. With that demonstration, you know what a cow member is. And now let's get into the load for the cow member. And let me turn that vertically to horizontally for the sake of presentation, easy to present. So let's put the member horizontally here. And if we have the actual axis of this member is go through the center of that member. And for the load, we call it centric axial loaded. So that load, it will be go through the central axis, that P. And to determine the internal force, as you already know, we will cut that member. So let's cut that member at section AA. And we can either to consider the left or the right side of that cut. So let's consider the left segment of the cut. Left segment of the cut. And consider the load on the left side. So as you can see, only 1P on the left. And then when we cut that member, we have exposed to for 2D exposed to maximum 3 internal forces, and we just reviewed earlier. We have a normal force, shear force, and then internal bending moment, called MI. And for a transverse cast, as you can see there, that for transfer cut, the cut that perpendicular to the actual, the centric axial axis. From that, as you can see, the N we already know, N is the normal force, V is shear force. And for this case, as you can see, with the equilibrium, we can see shear force equal to 0. And then the normal force, it will be equal to P if we have sum of all the force in x direction. And of course, for the cow member, the load applied through the centric axis. So with that, the internal resisting moment also equal 0. That MI internal resisting or bending moment also to be 0. So that only one internal force left is the normal force. So that is similar to the two force member in the closed member that we study in engineering mechanics. And that normal force going to create a normal stress, and that is the topic we are going to explore now. So let's talk about the normal stress. And for normal stress, it call it as sigma. To spell out, it will be sigma. So let's present a member in 3D. With the applied load P, go through the center of that member. Then we will have a normal force if we cut, for example, a transverse cut through a member. Then we have a normal force go in opposite direction and same at the load P. And for the normal force, it will create a normal stress that measure the intensity of that normal force. And that we call it sigma. That distributed throughout that transverse cut. And that called sigma. So let's have some presentation about the characteristic of the sigma. So first, sigma, and you can see here, it like normal force is perpendicular to the cut face. Like normal force is perpendicular to cut face. In this case, it's a transverse cut. And then the second characteristic of sigma, the normal stress, is it will be the same direction of N. So it is same direction of normal force N. So from that, we can have the equation for the normal force, a normal stress, as is a measure of the intensity of the normal force, and it also the force per unit areas. So let's call the areas of this cut, the area of that cut, EA, and define that in the area of the cut face. Then we will have the sigma normal stress equal to the normal force divided by the area of the cut face. And as previously showed you, for the cow member, centric axial loaded member, the normal force equal to P, so that it also equal to P over A. So let's box that equation. So that basically the equation of the normal stress. Normal force create normal stress, and that measure of the intensity of the normal force over the unit area. So for that, you can see where A is the area of cut face. So that is the normal stress. Before we move on to another type of stress, with the shear stress, let's go to the worksheet number 1C and 1D to practice about the normal stress.